Okay, I'll show you a problem on transformations that is not exactly like the ones in the practice test. And the reason I made this one a little bit different is because sometimes people can get through this problem or problems like this on the practice test by simply entering f of x into their graphing calculator and hitting the return button, which doesn't do me a lot of good in terms of evaluating whether you know what these transformations do to a graph of f of x. So we're going to go over, well, what does 2 times f of x do? Well, not knowing what exactly the rule is for f of x, we can't just enter it into a graphing calculator. But we can realize that basically multiplying by 2 the output by 2, that is multiplying the entire function by 2, has the effect of stretching it horizontally, stretching the function horizontally. So if this point here is 2 units high, then its image in 2f of x is going to be 4 units high. If this point is at 0, twice 0 is 0, so that point's going to be there. This point is 1 unit below, then its image in 2f of x is going to be 2 units below. Back to 0, and back to 2. So this basically multiplies all the outputs by 2, and it stretches things out, makes things taller. And this is what roughly, if I drawn straight, I don't want to redraw that here. Oh, yeah, I should. Redraw the curve so that it actually kind of hits the points. There we go. Okay, there's 2f of x. What then does multiplying by 1/2 do? Well, it should shrink it. Okay, multiplying out the output by 1/2 shrinks it. So this is 2 output. This point at x equals 1/2 becomes output 1. Again, 0, just 1/2 times 0 is 0. 1/2 the output here is negative 1/2. 1/2 the output here is 0. 1/2 the output here is back up to 1. And so in orange here, we are going to sketch the graph of the function y equals 1/2 x. Okay? Well, then we get to what happens when we multiply not the output of the function, but the input of the function. And just like translation worked the opposite way you'd think it would with inputs, so do stretches and compressions. So multiplying by 3 stretched output, but multiplying the input by 3 actually compresses. So everything, the x's are about 1/3 as far away in the image as they are here. So here x is 0, so that stays where it is. Excuse me, this is the original, so this is where it stays where it is. Let me just get those errant dots off. Here we go. This point here, when y equals 0, occurs at 1 in the original function, but it's 1/3 of the way back for the function f of x, f of 3x. Okay? So we scrunch it in 1/3. Okay? And then we've got this upper point here, this maximum here at 2, occurs at 1/2. Here in the image function, it occurs at 1/3 of that, or 0.5 here, negative 0.5. So here is the function multiplied when the input is multiplied by 3. When the input is multiplied by 1/3, you should be able, you realize that it's going to stretch it out 3 times as much. So again, input 0, that stays pretty much the same. Input equals 1 at this point here, well, that to get the same output, we go to input equal 3. And here we go to input equal negative 3 to get kind of the image of this point in f of 1/3 x. Finally, you get this maximum. This maximum occurs at 1.5. Here it would occur for 1/3 x, it occurs at 4.5, 3 times this. And so we go with negative 4.5, 3 times the input to get the same output of 2. And so 1/3 has this effect of stretching. Multiplying the input by 1/3 has this effect of stretching things out. So knowing what stretches and compressions do to a function is going to be important. It's not going to be as simple on your test as entering the function equation into the graphing calculator and messing with it there. You need to know what these stretches and compressions do, as well still, of course, as the translations. Hope this helps. Good luck on your test on Monday.